For this project, we need 4 wires that are gonna send us the data of the 4 buttons. When it's pressed, these wires will inform us through the Arduino. And then we need 5 ground wires. Okay, as the board itself has only 3 wires, but we have 4 buttons, which means we need 4 ground wires. And there's a trick to that we can use later. Now we're gonna set up the buttons. Make sure that it's rotated to the long end and that it goes across the valley here. Okay, we have the button set up. Now it's time for the wiring. So, as you can see here, there are 2 legs, the left leg and the right leg. You can put it on any wire. I'm gonna put the orange wires on the left leg. And then I'm gonna put the ground wire on the right leg. We'll do 13. We'll do 12. We'll do 6. And then we'll do, actually let's go a bit lower. We'll do 4 and 5. Okay, that looks better. So we have the yellow button connected to pin 3, blue button to pin 5, green button to pin 10, and red button to pin 12, and this wire connected to the ground. Now we have set up the hardware side of things. We'll now be moving on to the software side of things, where we will illuminate this. This here is a basic setup of our project. So this is the first place digit, this is the second place digit, these are the operators, and this is the equal sign. So the way I'm thinking about implementing this is we split the LED in half. Not in the literal sense, but in the software sense. So that here we can show 1, here we can show 3. It'll be split in half, but then later on in the software we're going to combine them to show the number. And the way we can do this is by going back here. This is going to be a pretty manual process. Number 1. So what we have to be aware of is that we have 8 rows and we have 12 columns. But since we're splitting it in half, we're actually going to have actually, yeah, 8 rows, it's still going to have the same height, but rather than 12, we're going to have 6. And then we're going to add them together, and then we'll display the number. So 8 and then 6. And look at that. This doesn't look the best, in my opinion. Okay. Cool. Number 2. Okay. Number 3, 4, 5, 6, 7, 8, 9. Oh, okay. So we have these 1 to 9 numbers. Going back to the whiteboard. So now we are able to draw both of these numbers. Let's actually, okay. So we have this. We should also set up the pins. So int first digit equals, first digit is going to be equal to 12. Second digit is going to be equal to 10. Operator is going to be equal to 5. And then equals is going to be equal to 3. Why is there an error? Okay, maybe it's because of the word. Because I know in Swift, if you write operator, it'll give you an error. Okay, now we have the pins down. Let's set up the pins. So pin mode, input pull up, boom, boom, boom. Okay. And then now we are going to okay, first we need a function to actually add the void combine numbers. Okay, this works. Yeah, this works. And then byte results. So this is our result matrix. Because we added that, we will not be needing this. It'll automatically update it here. So let's do number 1 and 2, and let's load the pixels. And I will be connecting this to the Arduino now. Let's run it. Oh, there's no loop void. Okay. We see that it is able to display the number 12. Let's try a different number. Let's try 26. Yep, and we got the number 26. Yep, and we got the number 26. So our next step now is to be able to press these buttons to change the numbers. So what we need to do is first set up a way to listen or to detect when the number is pressed. So usually what you would do is, so int button, the first button, yeah, state works. And then you do this, you do digital read. And because it's a pull-up resistor, pull-up button, when it is not pressed, it would show 0. When it is pressed, it would show 1. So not pressed equals 1, pressed, yeah. Okay. So now we just need a bunch of if statements. If, so low is another way of saying 0 in Arduino. So if it equals low, you just add the numbers up. And yeah, so you know what? A better option would be to add the matrix.load pixels within this function. And another thing we should do is refactor this. Okay. Display combined numbers. The reason I'm refactoring this is because combined numbers may be confused with adding the numbers up, like the add operation. So it will be switched to this. Okay, this is completely wrong. We need if. Actually, I think it's better if we add else if, because that way, if a person is pressing 2 buttons at once, it'll always, you know, take into consideration the equal button than all the other buttons. So we should also add another variable, int current operator, first digit, second digit, and we also need here or actually we need a macro expression that is able to this is wrong. Return the okay. And now we have first digit. So if the first button is pressed, it would be first digit plus 1. Okay. number 0. Oh, we didn't add number 0. I just realized. Okay, this is added, and we're going to do the same thing for this. Second digit. Okay, and we also do need a delay of, 200 works. Now let's run the project. So let's press 1. Yeah, this is a bit of a problem. I can hold it down and it'll cycle through it, which is not what we want, because it's easy to misclick a number if you hold it for too long. And I also realized another flaw I made, that the red button should control the second number and the green button should control the first. So we can just fix this by swapping the pins. So now the red button controls the right side, and this green button controls the tens place. Okay, now that this step is over, the next step is to add the operators and then the equal sign. I mean, the greater issue here is that there is a, not enough of a delay. So let's put 300 milliseconds for now. We'll fix this later. For now, we need to add the operators. So byte addition operator. Okay, that looks much better. Okay. Now, okay, it's just a slash, which works. Okay, now void display operator. Oh yeah, we're not allowed to use the word operator. Display math operator. Okay. Display math operator. We do this when the operator button is pressed. Okay. Now let's run the code. Okay. Let's do let's do 35 plus, so minus multiplication and division. Okay, now we just need to add the logic to the code for this. And then, so we just do first int first number is equal to 0. Second number is equal to 0. Result number. Sure. You know what we should also have? Or actually, no. Okay, so when you press the display math operator, it'll add the number. So first number is equal to first digit. No, second digit times 10 plus the first digit. But there is an issue here. If the second digit is 0, then yeah, it won't work here. So first number is equal to first operating number, second operating number. Okay. First operating number. Oh, no, I was wrong. Okay, second digit can be 0. That's fine. And then okay, here it'll just do all the work for us. Hello. I'm screen recording, so don't talk. Now we need to display the result. Yeah, this works. So now we should be able to run the project once more. You know what? I'm first gonna remove the 26, number 0, and number 0. Now we have 0. We're gonna 1. Let's do 5 times let's do 5 times 6. And it gave us 0. So the reason it gave us 0 is this code. Right here. Because when you're switching the operator, okay, so this operator logic should actually this logic should actually be in the equal. No, not the equal. Okay, clear them. So we'll delay by 400 to allow the operator to be visible, and then we're going to display the number, right? And then when the user presses on the new number, so okay, second number input is true. We're going to fix this. Okay, whatever. Second number input equals false. And then we're going to put an if statement here. If second number input, we're going to do the math. Okay, now it should work. Let's do 3 times 4 times 4. That's not a good sign. Oh, it's because the if statements are ahead or are after displaying the numbers. So, oh, it's because the if statements are ahead or are after displaying the numbers. So, now it should work. Okay, let's do 3 times 4 again. Times. Let's do 3 times 2, or 20, which should give us 60. Here we created the calculator. We should also make it that once you press equal, it resets everything. Yeah. Let's see what happens when you do 99 plus 10. It shows 0. It should give us 109, but that's completely fine as this Arduino can only display 2 digits properly. That's it for our project. Let's see if the reset works. 12 plus 1. It gave us 31. Or was it 21? Okay, I think it was 21. I put it first. So this is the end of our project. We have a working calculator that can perform basic operations with two-digit numbers. And yeah, like the video, subscribe. That's all. I'll also post the code online for you to see after the video ends. And yeah.